Hi, I'm Giuseppe Zappia, AI/ML Specialist Solution Architect at AWS. In this video, I'm going to show you how to build out MLOps capabilities to track model training experiments, debug model training logs, build repeatable ML training pipelines, and use a model registry for release management. Implementing these capabilities will allow you to implement reliable experiment tracking, reproducibility, and traceability across your model development workflow. As companies progress through the MLOps maturity cycle, there are different goals or intended outcomes for each level of maturity. During the initial stage, we are trying to quickly get our POC together to determine whether to pursue it further. In the repeatable stage, the priority changes to reducing build time to allow for quicker iterations with less required human interaction. In the reliable stage, the focus shifts towards observability and continuous integration to reduce defect rates. Finally, in the scalable stage, it's about time to value. This involves creating reusable blueprints and templates along with shared infrastructure and centralized capabilities. In this video, I'm going to focus on the repeatable stage, showing you how to leverage experiment tracking in automated pipelines to reduce build times for fine-tuning FMs. Let's get into it. An Amazon SageMaker AI pipeline is a series of interconnected steps in a directed acyclic graph, or DAG. These steps can be created through the visual editor that you see here, through the Pipelines SDK, or the JSON pipeline schema. When the pipeline is executed, steps are run based on the data dependencies between the steps, as well as any conditional steps that control the flow of the graph. The example you see here is a simple DAG with sequential steps that start with data pre-processing, then model training, deployment, and evaluation. Let's look at the code to generate this pipeline in more detail. In this notebook, I'm going to show you how to use the Pipelines SDK along with step decorators to create and maintain your pipelines through your local codebase. This method allows you to quickly iterate through developing the pipeline while still being able to execute it in a repeatable fashion. Pipeline execution could occur in a variety of ways, including directly from this notebook via the SDK, scheduled pipeline executions, and through event-driven architectures based on data landing in S3 bucket or model evaluations reaching a particular threshold. First, I'll set up some of the basic configuration parameters that will be used during pipeline execution. When using a step decorator, each step is run through Manage Training Job under the hood. Based on the amount of compute required for the step, you can specify different instance types to meet the need. In this example, I'm using ML M5 extra large as my default instance type. Because I reuse the same instance type, I can use SageMaker warm pulls. This keeps an instance ready, shortening the startup time for later pipeline steps. Being able to track all of the training runs is important to be able to see changes in performance or infrastructure utilization as training parameters and data changes over time. I'll use SageMaker AI with MLflow to track these runs through a few lines in my training script. This pipeline will fine-tune and evaluate a DeepSeek distilled Llama AB model. It is a best practice to store model artifacts in S3 rather than repeatedly pulling them down from Hugging Face. So as a preparation step, I'll stage it there. This will improve the performance of model loading in the training job and reduce the number of external dependencies. With that taken care of, I'll start defining my pipeline steps. I'll be using the step decorators for each step that will allow me to define individual steps right in my notebook. I give my step a name, an instance type, a label, and a keep alive, which is what will allow me to use SageMaker warm pulls for other steps of the same instance type. First is the preprocessing step, which pulls down a dataset, applies transforms like a prompt template, then stores training and validation splits in S3 to be used by the training job afterwards. Next is the training job configuration and script definition. This step will execute a training job on a separate GPU instance and track the experiment parameters in MLflow for later inspection. After training completes, the following step is model deployment. This step could be achieved in a variety of ways, including hosting the model locally inside of the step, but for illustrative purposes and to test for deployment issues, this step deploys to a SageMaker managed endpoint. With the endpoint deployed, the following step performs model evaluation using light eval to generate statistical analysis on the model responses. While I use light eval in this example, you can replace it with any evaluation framework that you like. These results will be output from the step and can be used as part of a conditional step to decide what to do based on performance. With all of the individual steps defined, we can now assemble them into a pipeline. Here you can define the input values for each step, how they correspond to the outputs of previous steps, and how the steps are connected to each other. In this example, the steps are a simple sequential workflow, but SageMaker Pipeline supports complex logic, error handling, and retries as well. I assign all of the steps into the pipeline, and then use the upsert API of the pipeline to create or update the pipeline definition. Once the pipeline is deployed, I'll create an execution of the pipeline by calling the start API, which will kick things off. Let's take a look at the pipeline execution, then the experiment details. As you can see in this pipeline execution, all the steps I walk through are here and denoted with green check marks showing they are successfully completed. If there were any errors, they would show up with a red X. Clicking into any of the steps provides details into the step's execution, including the start end times, the duration, and links to logs for auditing or debugging. The Settings tab also has references to the code that was executed in the step, which is stored in S3. SageMaker AI with MLflow provides a managed MLflow experience, including experiment tracking, model valuation, and a model registry that integrates with SageMaker model registry for model governance. Implementing a model registry allows for additional controls and reviews for deploying models, as well as a place for model discovery throughout an organization. Models can be versioned and flagged as approved or rejected for release, which can be used as events for automated endpoint deployment pipelines. Going to one of the experiments in MLflow, you can see a variety of information related to the training job. In the overview, this includes all of the hyperparameters that were submitted. This is crucial for comparison across training jobs to determine which parameters have been changed and then correlated to the performance of the resulting model, informing subsequent training runs. In the Model Metrics tab, you can see a view of metrics such as loss over time to determine things like diminishing returns or overfitting. Switching to the System Metrics tab provides a view of the infrastructure over the course of the job. This allows the teams to understand areas that may be bottlenecks, over-provisioned, or areas for optimization to get additional performance out of a later training run. SageMaker AI also has support for third-party applications that you can integrate into your ML platform. With Amazon SageMaker Partner AI apps, users get access to generative AI and machine learning development applications built, published, and distributed by industry-leading application providers. Partner AI apps are certified to run on Amazon SageMaker AI. With Partner AI apps, users can accelerate and improve how they build solutions based on foundation models and classic ML models without compromising the security of their sensitive data. The data stays completely within their trusted security configuration and is never shared with a third party. Currently supported Partner AI apps include Comet, DeepChecks, Fiddler, and Lekera Guard. These Partner AI apps help customers address key challenges like observability, model evaluation, and security without the need to build or manage it themselves. You can view more details on each of them in the Partner AI apps section of the SageMaker AI console. In this video, you've seen how to use Amazon SageMaker AI pipelines to build automated ML workflows, allowing data science teams to focus on building models without the heavy lifting of managing the lifecycle of those models. You also saw how SageMaker AI with MLflow can simplify experiment tracking and provide insights into model training performance, so that data scientists can efficiently optimize their training runs. Thanks for watching and happy automating.